think it's press. We stole it. Oh man. How are you?
If everyone can move back to their seats, we're going to get started with our next symposium.
Hey. Yes.
Hello, everyone. Welcome back. We are almost ready to start the last part of talks of today. And after we have the ECN business meeting. So our first presentation now it's made by Rachel Behm and David from the University of Central Florida.
Thank you.
Let's start.
Hello. Thank you all for those that are eating in the back and those that are already seated down, whatever, still learning English after 6 years in the US. Today I'm gonna talk about the update that we had since we started the World Economic Database roughly 2 years ago. 1 year ago, I gave you a sort of presentation of the project. Today, I'm going to give you what we've done so far, and that would be my part, and what Rachel did to sort of improve the community and the interrelation between the different people within the economic community. So just to give you a rundown of why we started the World Economic Database, simply because we had there we go. Yeah, it's working. Before the World Economic Database, which is right now the largest database for economic, we had Taxapat. Taxapat came into 3 versions over the years. One was in 2005, the other in 2012, and the 2016 was the last version of it. So every single time that you got an update, you got more taxa on it. But every time you got an update, you also have to pay $200 for it. So it is pretty costly over the year. After 2016, this is the look of Taxapat. After that year, we didn't have any major update. So you're looking at roughly at 8 to 10 years of not data input into Taxapat. And Taxapat was pretty big. It contained taxa from Ichneumoniid and Braconiid, so more than 52,000 valid names, more than 16,000 synonyms. That contains biology information, contains distribution. And over the years, the 2016 Taxapat roughly obtained more than 1,000 citations. This gives you the percentage of how many people use this and also how important it is for the community. However, after Taxapat closed the doors in 2016, we left with nothing. And this one sort of steered me to starting the project of the World Economic Database. Right now, after 2 years of this, we have our public page. With that over there, it's our URL that you can use and check it out. However, it is majorly incomplete. As you can see, we have only 5,000 scientific names, and you can see the comparison between valid species and also invalid names, synonyms, and all the other stuff. This is powered behind, we have the platform, which is in TaxonWorks, of course. We have more than 2,500 references as of now. This is a huge major resource also for PDF. So you can imagine that you can start right now with a solid base. We have more than 19,000 citations, which means every single species has a complete taxonomic history. And then we have more than 800 images. And right now, more than 1,800 specimens which are mostly type information. Of course, this is not nearly enough, and we do not think it is in the right place. To give you an idea of how the things gone in these 2 years, let me give you a rundown of the input of taxonomic name included into TaxonWorks, and therefore into that page that you see. You can see that in 2022, when we started, it was half of the year. We just have over 1,000 names. 2023 was a big year for us, more than 2,000 names. And then 2024, we got a diminishing. So we are closing the end of the year. We still do not have close to what we had in 2023. If you're asking what happened, that's the end of my PhD, okay? However, if you check the images, we have slightly more input over the years. This is because the database has increased interest within the community, but also because inputting images or giving us images, it's easier than actually inputting names. And one major thing that happened since the database has been created, has been funded, is that some side project came out of TaxonWorks from the World Economic database. One of this is the update of the Italian fauna of a checklist of the Darwin wasp or the Ichneumoniid. This has been carried out by Filippo mostly, and he gave information about records by region with the references and with all the synonyms correlated with each of those references. And this will workflow into the World Economic database. So it started from using the World Economic database. You got a side project that then goes back again into the World Economic database. So this gives sort of platform also for the different authors, different experts in the Economic to use and abuse of it, and also use it for publication and for their own CV. So right now, this is the map of all the people working within the World Economic database. All those dots represent a person or an institution in which they're working on. And these are the people, they're popping up slowly. Not all these people work the same way. Of course, some of them are simply pledge allegiance to us. Some other are simply giving us images. For instance, right now, since we're talking about collection, the Natural History Museum with Gavin Broad they told us they want to give us their primary types, their holotypes and paratypes as much as they can. So this is what we have. We got a few amount of people, however, not enough data. And this is because we are facing major challenges. One of this, it is an ambitious project. And it's not limited just to transfer of data between Taxapad 2016 to the actual World Economic database. We have all the taxa that in those 8 years, and also we have all other major information like images and taxonomic history of the single names. Moreover, we are checking every single reference to find that specimen or that synonyms. And of course, there is a lot of data to input, and this is one of the major problems. And then we have problem with consistency and standardization between the different people that working with Ichneumoniid. And therefore, we had major trouble in organizing and communicating to the community and receiving feedback from the community. This one is, I think, one of the major holes that we have with the World Economic database. This is why a few months ago, we decided to hire to the highly salary of $0 per year with zero APR, our project coordinator, Rachel Behm, which actually saved us.
Hold on about that. Hello, I'm like half Davide's height, so sorry about that. So I first got involved with WID because I wanted to, of course, help and input data into WID from my master's. I did systematics of Ophionenae, and I said, I have all this data, I have all these resources, I want to incorporate that. And then knowing Davide saw that I could get more involved and help solve some of these problems or tackle them. So first thing I did is I wanted to get information from the community, all of those people you saw on that map, and the current people who were interested in already working before, bringing in more people. So I did that by reaching out to everybody and saying, either email me responses to some of these questions and on this Google form. Send it to me, and then I can yap at Davide to tell me how to do things, and then I'll show you some of the things that come out of that. For example, what I wanted to know from people is what they were working on. So either maybe a certain taxonomic group like me, or things like with Gavin Broad wanting to contribute images, or maybe they're working on specific groups, et cetera, et cetera. If they were working on something, I wanted to know what the hangups have been, because like Davide said, there was like a lapse of some inputs. I wanted to know what were the hangups, what was happening. And then what would be helpful to either get you back or to move forward, what would be helpful things to have. And overwhelmingly, people wanted a manual, a nice standardized manual with step-by-step instructions, images and screenshots of the actual TaxonWorks database as you put in all those things. That's organized by task base and case use for different things that you want to put in, with examples and clear definitions, because a lot of time when you step away, because a lot of these people would get busy with their own research, and it could be pretty intimidating to come back and work with, you know, this big resource. They wanted to do the best they could. So I deep dived into TaxonWorks as a whole, into all of the material, everything that was TaxonWorks based, because I too wanted to use this great resource, in Word especially. So of course, the way you do that, for me, what are people already doing? Primarily, the resources within TaxonWorks, their help guides, the videos that a lot of wonderful people have put out, the manuals within TaxonWorks itself, as well as a special thank you to the Chalcedonian database. They have a wonderful, amazing step-by-step checklist of all the things they've used that were a huge help. Even though we were doing slightly different things and with slightly different goals, it was so wonderful to have just a base resource. So as of June 2024, I made, as those things I talked about in the previous slide, a step-by-step task-based with case uses, with definitions, with screenshots as I was walking through myself, with timestamps of the videos that were already made. Of course, if there were, I would put notes in if we were doing things a little differently than the Chalcedonian database, for example. And the other thing that people really wanted and were really interested in is a better way to connect to each other. So of course, opening communication channels. So I made a WhatsApp. I make sure to we want to have constant contact, making a like ECN, a email listserv. We want to have scheduled meetings where we can all, you know, I sent out that first 30-page manual for everyone to try and use. I want feedback back so I can make it better. Of course, expand. It's 30 pages as of June. I've already continued to work on it, expanding what has been task-based. And of course, once things are more settled, get help from all of you to contribute more data. So have a better way to do that. And of course, Davide can probably speak more on this, but we're planning to actually have some publications like, based on WID. So Davide, if you want to finish it out.
So we would like to thank everyone who helped us. So the curator, of course, in the World Economy database, the species file group, Debbie is here. So thank you so much for all your help. And then the potential future users, also communicators, whatever, for the World Economy database. Oh, by the way, we have a fantastic logo that possibly you haven't noticed, but it's wonderful. And also the UCF, the University of Central Florida, for the presentation found for this conference. And with this one, thank you all. So mostly we are interested in types to start with, but I'm including also other type of images that are important for identification. One of the major impediment in the Economonid community is that we don't have images whatsoever of the specimens. So we don't have access to the specimens, maybe because there are in 3-4 major collections, right? And so any kind of image, it's wonderful if they are authoritatively identified. But we would like to mostly have types because that's what the tool of the game.
if I could quickly add to that, one of the crazy things as an INAT obsessed person, like has been previously discussed by other people, when I'm putting in the taxonomic history, especially for Ophionidae, a lot of them don't have as good of diagrams as I would like, or images. I've actually been, as I've been identifying Ophionidae in INAT, have actually been finding species that have pretty clear descriptions that have never been imaged, and actually being able to tie that back into the World Ichneumonid database and actually having that nice reference. I'm sorry.
Website for DQU. This is not very old, it's a startup. There's other ecomodic resources that have become static since the caretaker retired. Bob Barton is extraordinary database and database. I don't know if it's ever been worked on since retired. Would you be able to acquire that?
No, unfortunately not from Bob Warden, and we don't have real permission from DKey actually, but we are actually manually right now transferring all the data. Okay, so we're not doing it by taking his database and transferring it. There has been talk within the species file group to sort of mine the code and try to transfer those data. Those data are available somewhere if you pay the $200 fee, but we don't have direct connection with DKU right now. So the 5,000 are mostly me, Rachel, and Filippo inputting names. Yeah. We are also working with the WASP web, by the way, to get images and types from there. Yeah.
Let's see, is this height proper? Okay. Good afternoon. I'm Zack Falin, and I've been a collection manager at KU's Biodiversity Institute since 2003. I didn't realize our new institute director would be in the audience today, so I hope I'm not going to get myself in trouble. But I'm here today to introduce you to, I'm here today to introduce you to Dave Broska and his fantastic tiger beetle collection. I have a lot of ground to cover and will gloss over many small but important details. I'll be happy to chat about them in greater detail later. Dave Broska grew up in Wilmington, Delaware, and received a BS in biology from Marquette University in 1969. He went on to get an MA in theology, but then switched gears again, getting an MS in entomology and a DDS from Ohio State in 1976. Collecting insects, especially beetles, especially tiger beetles, was his passion. Dentistry was merely an effective method to pay for his field trips. And that's pretty much a direct quote. After graduating, he bought a practice kind of randomly in Lawrence, Kansas in 1976, retired from dentistry in 2003, and moved to Naples, Florida, where he lives today. He started collecting in Wisconsin before his undergraduate degree and finally hung up his net shortly after his last international trip in 2017. He traveled extensively in between, visiting virtually every US state and Canadian province, eventually collecting in at least 66 countries around the world. Mexico is one of his specialties. He made at least 24 trips there, ranging from a day or two drive over the border to weeks-long expeditions. And I'm hedging here a little bit. He actually has pretty good field notes from 1982 onwards, though there very much are some gaps. Even with his notes, his activities are challenging to track. He would routinely collect outside the local airport during international layovers and near the docks during multi-island Caribbean cruises with his wife. Although I've cataloged well over 400 more or less discrete collecting trips domestically and abroad. By retirement, he was quite literally spending more time in the field than at his practice. In addition to his own field efforts, he actively traded specimens with other amateur tiger beetle enthusiasts, which, as we'll see, adds quite a wrinkle to the processing of his collection. Not surprisingly, he befriended the late Steve Ash, my PhD advisor at KU, while at Lawrence. He participated in numerous KU expeditions and donated a significant portion of his non-tiger beetles to KU in the late 1980s in order to make room for more tiger beetles. Then between 1990 and 2006, he struck a gentleman's agreement with Steve and began donating his tiger beetles to KU in 10,000 specimen chunks for tax purposes, eventually donating about 170,000 specimens, or about 2/3 of his collection. In 2022, he signed over the remainder of his collection to KU. The curious part here is that he retained physical possession of the specimens throughout, taking his collection with him when he moved to Florida. In the last few years, his health has deteriorated to the point where he is no longer actively working on his collection. And after hurricanes struck Florida in 2017, 2018, 2022, and 2023, we mutually agreed it was time to bring the collection home and retrieving it from Florida in October of last year. So what exactly is the Brodska collection and how did we get it back to Kansas? The collection consists of about 550 Cornell-style drawers in 45 open-face cabinets that were custom built into a small room in his house. In addition to the pin tiger beetles, Dave had about 1,400 ethanol vials of larvae and adults in metal filing card drawers, 63 Schmidt boxes of non-tiger trophy specimens, and a small library. Dr. Rachel Osborne, the second collection manager at KU, graduate student Peter Willison, and I flew to Naples with 2 action packers full of supplies and spent 5 very, very long days on site preparing the collection for travel. We brace pin specimens when necessary, blocked in the unit trays with cardboard wedges, and packed the drawers back into their original cases once they were removed from the room. We then stretch wrapped the cases, lined the bed of a 26-foot box truck with carpet padding, then dense packed the cases so as not to allow any movement during transport. All of this worked really quite well, so if you're interested in the details and have a project of your own, please find me later. And probably our most brilliant thing is we hired a professional driver, because I wasn't going to drive the 26-foot truck back to Kansas. Flew him down to Florida the day before we finished. Then he and I made the 1,400-mile drive back to Kansas in about a day and a half. Altogether, it took 4 people, including the driver, 1 week to arrive on site, prepare the collection, load the truck, and drive it back home. It took approximately 134 hours of on-site work to prep the collection and load the truck, and cost roughly $14,000 plus or minus. I don't have the exact figures on me, not including our 3 salaries. There were some hiccups. First, while the curation was generally excellent, there were virtually no determination labels on individual specimens. Rather, there was often just one header card with a taxon name at the beginning of a species, and frequently, a single species spanned multiple drawers, such that we had to make absolutely sure that every drawer was numerically labeled, removed, prepped, and replaced in the exact order in which it was found. Second, we hadn't anticipated that the cabinets were all attached to each other, the walls, and the built-in tabletops. And given the extremely tight room, we had to remove and prepare the cabinets according to the Tetris-like architecture of the room, not in any kind of taxonomic order. Lastly, no one mentioned that the AC wasn't working, and we spent 10 to 14-hour days chugging Gatorade and sweating profusely. In retrospect, it would have been a much more humane process if we had allowed at least 1 or 2 more days on site. I did my best guess to see how fast we could do it. Once we got the collection back to Kansas, the obvious first task was to create a detailed taxonomic inventory, counting all the specimens and creating temporary taxon labels, the little green things there, as a hedge for unit trays or entire drawers getting placed out of order. And here are the results. And I'm not going to spend much time on this, but my impression is that it's probably one of the best private collections of tiger beetles in the Western Hemisphere and in the top 2 or 3 private tiger beetle collections in the world. This inventory process posed challenges as well. The sheer size and complexity of the collection makes it daunting to work with. We had to put it in 3 different rooms when we brought it back. Likewise, the collection is arranged by biogeographic region, so occasionally taxa from adjacent regions are in 2 different places. actually 3 different places, because Dave had separated out representatives of each taxon in a physically separate synoptic collection. Even more frustrating, Dave meticulously used subspecies in the synoptic collection, but rarely in the main collection. Specimens were often separated into more or less discrete series in the main collection, but their identity was not noted and can't be directly correlated with explicit taxa in the synoptic collection. So the last stage of this process is accessioning the unaccessioned specimens. As mentioned, we already technically own 170 out of the 254,000 specimens, mostly from the Western Hemisphere and Australia. Theoretically, all I have to do is compare the numbers of the taxa in front of me with our previous accession documentation, and voila. Not so fast. Dave had sort of mostly kind of marked unit trays of specimens that he considered donated, but his system was by no means comprehensive or uniform. Likewise, subspecies were not recorded in the original accession documentation, making the status of specimens in the synoptic collection ambiguous. And well, the numbers often just don't match no matter how you look at them, because he added new specimens to the collection after having donated a particular taxon, and he removed specimens from accession material to trade for other taxa. This is obviously problematic for a number of reasons, and I'm not going to say any more about that. And most troublesome, but not unexpected, Dave was rather inconsistent in documenting the permits and provenance for many of his specimens. He has some documentation, and we have some documentation for shared expeditions, but there are a hell of a lot more specimens than paperwork. So what did I do? I started with the lowest hanging fruit by examining the Nearctic section for federally threatened or endangered species. And indeed, I found some, and previously accessioned or not, those were physically isolated to deal with later. I then went taxon by taxon, keeping a running tally of how many more or fewer specimens were in front of me than I expected given our previous accessions. Simultaneously, I looked for and found specimens from US and Canadian national parks and reserves. Physically isolating them at this stage is impractical, verging on impossible, and most had been previously, if unknowingly, accessioned anyway. So I labeled those series as I found them, and labeled the drawers I found them in so that we can unambiguously find them later. They will have to be fully inventoried and dealt with in the future. It's simply not going to happen right now. Bowing to practicality, sprinkled with a generous helping of the benefit of the doubt, I have not been labeling specimens from state or provincial parks, and I'm allowing them to pass through the system. The little green temporary debt labels allow me to remove processed taxa and specimens from the collection, freeze them, and put them in temporary storage in the main collection room, and not goof up this positional identification. Now, most of the Nearctic material is finished, and I'm now adapting the process for other bioregions. And first, as far as I know, there are no CITES listed tiger beetles. Don't have to worry about that. If we have the documentation from an expedition, great. However, that's not true for a good portion of the material, so now what? Again, caving to practicality, I'm making an uncomfortable leap of logic as my next step. If we have previously accessioned material from a given expedition, regardless of documentation, I am making the assumption that we can accession more from that particular expedition. There just has to be a rational, if logically tenuous, way to move this process forward. After that, your guess is kind of as good as mine. There are going to be material from expeditions I know required permits for which we have none. Likewise, it will be virtually impossible to verify the provenance of most of his traded material. How much benefit of the doubt are we willing to offer? He did sign our deed of transfer stating that he believes everything was acquired legally, but with scant documentation, that is impossible to truly assess. In the end, there will no doubt be material that we just can't keep, but my working philosophy is that I'm performing and documenting as much due diligence as practically possible under the circumstances. Excluding the obviously problematic endangered species, should regulating agencies ask for certain material back in the future, that's what we'll do. In other words, it's a beg forgiveness rather than ask permission approach. really the only way we'll know exactly what is in the collection is by specimen digitization, and that lies well in the future. It's planned, but that's the future. For now, we are obligated to conserve this material in our possession, and I'm assuming we'll work out the kinks later. I'm also not going to mention that KU doesn't use Cornell drawers, and we're going to have to transfer all 250,000 specimens into our unit trays. And you can see from the photos, they're packed cheek to jowl. It's going to be a lot of fun. But anyway, this idea of accepting legacy collections is a really thorny issue for all of us. Applying kind of modern understanding of rules and regulations and procedures to amateur collections that span many decades prior. With that, I'll invite further discussion. Thank you very much.
So first getting you got into this legacy questions that are very important, but sort of organic, different they are. So I suppose if you were to create sort of guidelines or advice to these collectors or amateurs, how would you guide them to make their collections better, transferable?
I was asked to repeat that question, but I'm not sure I can. I would encourage folks to keep as much documentation as possible. And in Dave's case, he very often went on co-expeditions with us or with other experts, other professional entomologists who likely did have the documentation. Whether he asked for it or not, I guess generally he didn't. And so I would encourage anyone who's working with professionals or even as by themselves to keep everything as possible. And if I were developing a collection of this size and importance, me being me, I would have some sort of accession process even within my own collection, so that if someone asks, where did these things come from? You look it up. All right, that's the story of these things. One suggestion. How many folks will do that or have done that? I don't know.
Thank you very much.
Thanks. So today I want to talk about some figuring out geographic biases and social trends as inferred from digitized collections data. So this all kind of starts with this question I was thinking about: why do I collect in the places that I do? And there's a lot of reasons for that. Perhaps it's because of the circumstances of where I live and work. That's a really big one. Perhaps it's because one of you found something cool and I want my own. Or you found something cool of your group and I think maybe something from my group is there as well. Also, though, I'm really driven by going to places where there are no other records. So a lot of times I like to look at maps, figure out where there's no records, figure out if there's a road there. And that brings us to the Sand Tank Mountains, which is an area about an hour and a half southwest of us here in Arizona, a low elevation mountain range in the upland Sonoran Desert that only had one iNaturalist beetle record before we went there. And so this was actually part of a published study that we had last year with a bunch of colleagues from the ASU bio collections. We went out and we surveyed a bunch of the beetles from this area and started a checklist. But in thinking about that, how do we quantify collection bias across space? And so we can look at the state of Arizona, for instance, and here are 702,000 records with GPS coordinates. And we can just visually see that these are not distributed evenly throughout space. In part, we can see where the 3 state institutions are. These universities all have active collections with active digitization programs. So we can kind of see that. But if we look at this, instead of just dots overlapping each other and as a heat map, the population centers hardly even register. And we can see that all of the records are in the southeast corner of the state. Well, so again, how can we start to quantify this across areas? And so one way we can kind of regionalize the state is to look at ecoregions. So these are the US EPA ecoregions that more or less correspond to the different deserts in the state, as well as the uplands that separate them. And so we can then plot the number of records by the area of these. And we can see that there's a really big outlier, the southeast corner, the Madrayan archipelago area. But maybe this is biologically real. Maybe there's a lot more biomass of insects here. And so if you go out for a day there, you're going to come back with a lot more specimens in your collection. So instead, we can filter our results by collecting events, more or less. And so this was by collector name and date. So basically roughly equal to collector days. And we still see that there's been more collector days in this area than anywhere else in the state. And the next highest is at least 3 times the size, the geographic size of the southeastern portion. So, okay, so we're going here, right? But if you know anything about Arizona, it's all about mountains. And so we can think of the state differently in terms of the mountain ranges here. Here are 81 of the tallest mountain ranges that all have at least 1,000 feet prominence over the surrounding areas. So they might get into different habitat than the areas around them. And 43% of all the records in the state fall within these mountain ranges, right? Even though it's a small proportion of the area. And so again, we can map how many collecting events are there by the size of these mountain ranges. And again, we see a huge outlier. And these are the Chiricahua Mountains. Many of you have been there. If you've digitized specimens, you've seen the Southwest Research Station or Portal, Arizona many times. And there's 4 others that are not nearly as disproportionately highly sampled, but 4 other mountain ranges where I've run into many of you by chance in the field, right? In some of these canyons. So these 5 mountain ranges, right? What's kind of driving this? One thing could be access. Public lands and drivable roads are definitely a big thing, but 70% of the state is public land. So that doesn't really explain it. And actually, I think it's something that's more social. And actually, the birdwatching community has a term for this. They call it the Patagonia picnic table effect, named for another mountain range in southern Arizona. But basically, birdwatchers would stop at this picnic table, and as they're eating their lunch, would notice rare birds. They'd tell their friends, and everybody else would go there because that's the spot that you find rare birds. But later, researchers found you're actually not more likely to find rare birds there than you are anywhere else in those types of habitats. It was just word of mouth that brings people there. And so I think, that's what's happening in our community. And so with that, I was ready to write a discussion to say, hey, you guys should stop going to the Chiricahua Mountains and go to these other mountain ranges where we're trying to go out to. But in reality, if we look at a species accumulation curve of all the insects in the Chiricahua Mountains that are so well collected comparatively, we're nowhere near documenting all of the species, at least in terms of digitized data from these ranges. And if you're not accustomed to species curves, even though it looks like maybe it'll plateau soon, it probably won't because we haven't seen this plateau anyway. Anyway, so the Chiricahua Mountains are not anywhere near fully sampled. So the takeaways from this, collecting effort is clearly disproportionate geographically. And this is happening even across aggregation, right? So it's not just 1 or 2 collections and the rest of the collections will fill out the rest of the space, right? These are underlying trends. And I would argue that there are non-scientific factors that are affecting this. There is something special about the Chiricahua Mountains, but there's something special about a lot of these other places that we're not going as well. And in the end, I think it's still perfectly fine to continue to visit these classic localities. But maybe we also need to kind of think about going to some other areas. So for the second half of this talk, I kind of want to shift to a different area. Indiana is here in the United States, if you've never been. And there's a lot fewer insect records. But again, we can see from the map that they're not equally distributed. And Indiana, as of this month, only has less than 245,000 insect records. So much fewer than Arizona. And I think that's because none of you are probably planning your next big collecting trip to Indiana. And it doesn't have the topography to break out mountain ranges and things like that from the state, but there are a lot of counties. So we can still kind of regionalize it to start to get a sense of how disproportionate is collecting. And so if we look at the number of records, we can see that. And so for this, I kind of looked at, well, where are the data coming from for these records? And as we heard a lot about this morning, iNaturalist is the largest with over 100,000 records. So 40-some% of insect knowledge online in terms of records for the state comes from iNaturalist. Then the next one is vector-based. And so there are 76,000 mosquitoes only from Indianapolis, the largest population center in the state. So that county is a huge outlier, but that makes sense why it's such an outlier there. And then Purdue is in Tippecanoe County. So the Purdue Entomological Research Collection is the third largest contributor of Indiana records. And so those two counties can be considered outliers, kind of maybe from data provider standpoint. So then I try to look at the rest of these counties to figure out what is driving our knowledge or what's correlated with this increased knowledge. So far, I found a lot of things that are not correlated. Total area, it's not correlated to how many insect records we have. It's not correlated to how many people live in those areas. It's not correlated to the median household income of the people in those areas, or to positively or negatively with the percent below poverty line. It's not correlated to the number of post-secondary degrees either, right? So that's interesting. And also, it's not correlated to the amount of protected lands that you have in the county. So what is it correlated to, if anything? And it's correlated to individual people. And I think intuitively, this kind of makes sense to collections folks. But we can even see it in the data here. You might have noticed these odd shapes in the map. So here's this big grid. You're kind of like, what ecologist published that much data? But it's actually one person on iNaturalist who published over 57,000 observations. And actually, these are obscured data. So they probably live or work here. And so iNaturalist grids up the map. And if you post a record and say, I want to obscure my data, they plot it randomly within that grid. So all of those records have been, randomized and covered that grid. And they give the, error term with that. So you can still model the data afterwards. But there are other stories in the preserved specimens and other iNaturalist users as well. So it all comes back to these individuals. So I think there's something about how humans are interacting with nature that's kind of profound here. And we can even see this taxonomically. So other than mosquitoes, this is the most observed or recorded insect in the state, the common eastern bumblebee. 3,000 records from 20 data sets. And there's 5 counties that have no records, but there are many counties that have 100 to 200 plus records in that county, right? And we can compare that to the entire order of Blatodia with less than 300 records, right? And that's including termites. And so this isn't supported by the data, but I'm going to make a bold hypothesis that there are more reticulate termite individuals than there are bumblebees in the state of Indiana. So that maybe says something about our methods that we're using. And even if these are all coming from iNaturalist records, though, there's plenty of cockroach species as well in populated areas, and we're not putting those on the map, right? So I think there's something kind of fundamental underlying the types of data that are being published. And so kind of my takeaways from that are that individual efforts are really structuring and they drive our biodiversity records and what we know about the fauna of different areas. And again, these gaps and biases, they start with human behavior and are probably impacted by our uneven relationship to biodiversity across taxonomic and other dimensions. So really, my final takeaway from this is just keep collecting. And I think that's in a broad sense, physical specimens for our collections, but photographs and human observations are important too. And I think this has always been true, that our understanding of biodiversity, it's all about the dedicated work of individuals. And that's kind of the legacy that we've been tasked with promoting. And so I'll stop there and take any questions we have time for.
Okay.
Thanks. One thing I might say, I didn't have time. If we look at the types or how these occurrences show up online, human observations, even though there's a lot more of them, they are less species rich. Takes about every 26 records, you get a new species on average, versus preserved specimens, you're getting a new specimen every 20. And I thought that's kind of interesting, but I haven't quite figured out an angle to investigate that more. But anyway, thank you.
In Arizona, since you've done the study, is there any one location where you think it would be most interesting to collect with the lack of records in any vicinity or the density of records around it? Was there any one location that seems particularly lacking?
There's so many areas, and there's also a lot of reasons for those lacking areas. So we have a lot of Native American tribal lands that are difficult, or that you have to get access to, right? And so that's that. The other thing is that as a look at the state, we have a little bit of Mojave Desert, and that's very undersampled. But the Mojave Desert extends into states that probably are collecting there. But the Sonoran Desert, low Sonoran Desert, is very undersampled, and there's a lot there. So go sweat it out and catch some bugs is what I hear. Oh, I don't know. I didn't dig it. I saw that too, and I have no idea. Yeah. Yeah, there are a lot of folks that are working there, and there are some some of the tribes have their own colleges that have their own studies and are generating data, and a lot of folks have partnered there and done bioblitzes. But it's hard to, I think, overcome perhaps decades-long gaps in some of those areas, despite those efforts. But yeah, there are some of those.
Thank you very much.
Okay. All right.
Hello, I haven't moved. I'm still at the MCZ. Let me figure this microphone out. So this talk was meant to be presented by Christine Fernance at CSIRO in Australia. But we decided, since it was a long way for her to get here, that we're going to do a team talk. So I'll do the first half of the talk, and then she'll actually present a recording. She may be in the audience. I don't know if we're digital too, but yeah. So let's get started, and I need to adjust this because I'm short. Okay, there we go. So today, I'm sure you've all heard about lightning bug at this point, but I'm going to give a brief introduction to some of the work that we've been doing in the past few years, and give you some updates on some of our early results. First, this is not just me. This is a huge team across multiple institutions. This is an NSF-funded project to Yale, University of Florida, Museum of Comparative Zoology at Harvard, and University of Chicago and Argonne National Labs. And so I'd like to talk today about one of our biggest issues, which is transcribing the data off of specimen labels. You can kind of think of it as the final frontier, right? Like, we can sit all day and just type and type and type and type, but even doing that, something has to change, because it's going to take decades, it's going to take centuries for us to transcribe all of that data off of our labels, get it parsed into Darwin core fields, and then get it served out onto iDigBio, GBIF, and things like that. So the part of this that I'm most interested in, and one of the parts of this process that Lightning Bug aims to kind of speed up a little bit is, so you've got like your species inventory, then you might image your labels in order to get the data off of the labels, then you transcribe that data, you parse it into the Darwin core fields, and then hopefully you enhance it with georeferencing, with images, standardizing and cleaning the data. And so the part that we're interested in is this label imaging side. And for those of you who have worked on a digitization project in the past, you'll know that one of the standards is you remove the labels from the specimen, you put them on a little platform or stand, you take a picture of the labels, and that takes about a minute per specimen. It's a really long time. And so this workflow is aiming to speed that up a little bit. So enter Copus, which is a system that was developed at Yale with Nelson Rios. It's a multi-view imaging system, and we'll get into pictures of it in a little bit. But basically, we want to have two separate workflows for these specimens. One, which is a higher resolution 3D imaging workflow. And there's lots of great systems that do 3D imaging already. So you have like the macroscopic solution system, which we actually have at the MCZ, and it works wonderfully. But we're hoping that this will be used to kind of speed that up a little bit. And then you have this separate workflow, which is the label reconstruction. So taking those little partial images. So if you take a camera and you bring it all around a specimen that has labels on it, like you see here, you'll wind up with sort of partial views of that label, right? And you can read some stuff, you might be able to make out words, but you can't read all of it. And so what Lightning Bug, or what the Lightning Bug project is starting to do is we're taking those partial labels and we are reconstructing them into flat image labels that can be read or used in an OCR or HCR pipeline. And then if we want to, we can do community validation and transcription, or we can do in-house validation and transcription, finally getting into the structured label text and then out into the data dissemination. And so there's also a good case for high resolution specimen imaging as well. So it's high value data. It can be used for species identification, morphometrics, trait characterization, and a whole host of other uses. So we received this system. This is the Lightning Bug system from Yale University. They put it together with parts that you can buy from, I believe there's a website. I've been eyeing lots and lots of little parts off of that website. But basically, you can buy all of these parts off the shelf. And so this was put together at Yale. It was delivered to Harvard in October of 2022. And as you can see, it's a large frame. It has 2 boxes. And in each of those boxes, there are 3 cameras. Those cameras are on rails that move up and down, side to side. There are also gimbals that can pan and tilt the cameras as well. And all of those are driven by motors that move around the specimen. You can see we also have lighting set up as well. That gives the specimen really nice bright light. But we're actually finding that for the 3D imaging side of things, actually using the built-in ring lights in the camera lenses works way better than having these bright like panel lights. And so for the past couple of years, Zoe Flores has been working diligently every day running this system. She's received training from staff at Yale. You can see here, this is the Copus interface. And within the Copus interface, you can build paths. So you can decide how the cameras move, where they go, when they take pictures. You can have the cameras move without taking pictures, which we found was actually really helpful because often the cameras will get themselves into a position where they're like going to crash into one another. And so you have to have them move back into a different place before before they can take pictures again. You can see this here is actually the path that we've decided to use for our label imaging. So you can see it has two arcs, one that goes around one side of the specimen, one that goes around the other, and it's about at a 45-degree angle. You can see these are the image suites that it generates. So it's 14 images of the specimen and its labels. And for larger insects, this is actually pretty good for identification. For smaller insects, it's almost useless. But it's sort of a trade-off. The labels are really easy to read for the smaller specimens. So you have all of these partial views of the specimen. We also do a view underneath the specimen as well. So you can see we have, and if anybody has advice on this, we currently have double-sided labels for our barcodes, which are really, really nice because you can read them from both above and below. So we've decided to take one of those bottom cameras. So you can't see it here, but there are 3 cameras on the bottom as well. We've decided to take one of those bottom cameras and target it on the barcode label. So to date, we've captured about 80,000 images of specimen labels in about 9,000 sessions, which are specimens. And these are mostly focused on some of our historically important collections. And we're currently working on making some efficiency improvements as well. You can see here's a specimen from the LeConte collection. And what we've been doing is we've been taking this data and feeding it to Argonne National Labs. And computer vision specialists there have been taking those labels, so all of those partial labels, and they've been stitching them together and producing these label reconstructions. And we've started scoring these reconstructions. They're starting to look pretty good. They're very readable. And we're starting to score them for readability and the quality. So now I'd like to turn it over to Christine, who also just got a lightning bug system at CSIRO, and she'll do a brief introduction to what they've been up to with the system.
Started mentioning agency, and which is amazing when you start a national biological research trust. Today, I'm going to in our reports, between 15 million circles down wildlife, today, insects, cases, thousands, and use collection. Over half of all assessment in our collection are insects, over 2 months about solving insects. And the consolidation scheme is currently utilized the entire population of 18,000 types in the Australian Missionary collection is in the United States. We will read the first dialogue, identifying assessment and navigate on the When this will be used to have multiple doors in the collection, it will also affect the child with sensitive impact, assist navigable methods, and eventually inform theory actions, such as knowing what information we have relevant to the collection before it's actually. Therefore, the work has been regarded on research to reduce their ability to people. Unfortunately, things have to control the local time. These facts are to change machine learning models to enable autonomous. Using what in way populating medical and it reduces wear and tear on maintenance. Additionally, the massive environment being string together collaborators and linear organization based in applications. Our learning system is done in everybody comes part of this. The university environment is moving steadily assets to the chance to blend the learning parts and how they can be smooth on investment, goals at the level one. Immersive technology is also a great way to assess how we're putting on the future of the process before we take. In the immersive environment, persons who are local which strengthen businesses and restore, and suggest the order to the robotic arm can be a hospital in the immersive environment and determine the technical assessment of average hours and what that is the average student of the film. So we are officially outlining how to accelerate digitization for our user collection. The argument of the exploring procedure for working assessment smart collection, such as in our daily collection. Understand negative impacts of life work with these program collections to the set of recorded impacts that will exponentially increase digitized data and ensure sustainable digitization programs. Most importantly, like you are the limited needs to remove labels and services without entry transcription execution. Until now, this has been standard practice at this generation of collection. This will eliminate the biggest bottlenecks in the digitization program. We are also excited to explore the potential for using technology as and data. Thanks for listening to this talk. I hope you found it interesting.
Oh, sorry. Oh, thank you.
Ooh. Hi, everybody. Hang on. Mike's trying to leave the building. All right. So many of you know me already. For those of you who don't, you can find out more about me on the back and more about TaxonWorks. So here, I would like to say I'm very excited to be here to be talking about a subject that's come up in different ways in many of the talks already today. And from my background here, I'm an informatics liaison. I work between the software developers and the people adopting the software in the species file group. And we look to figure out how we can meet what you need. And I look to see about what you're asking for and what you might not be asking for. So we can figure out how to get you what you need and get the world what it needs. We have a lot of data, right? But we have issues. Issues with sharing that data, issues with data standardization, issues with things like data that gets abandoned, expertise or information loss. We have these sort of shared challenges across many communities. But what can we do locally in this talk? I'm going to give you very concrete examples of something I asked the developers, and they gave it to me inside TaxonWorks, and work our way all the way up to the 30,000-foot level to talk about what we can do as a community, what we can do as organizations. So we all spend time doing this. How many of you use or have to use or manage data in spreadsheets? Put your hand up if you're on the, there you go. Online, put a +1 in the chat. I think you're going to see a lot of ones. Think to yourself, you don't have to share this part. What tools and services do you use to do that? What methods? Do you have to pull it out of your database, do something to it in a spreadsheet, push it back into the database? Do you have to have special skills using R, Python, name your favorite? What is the next one is a community-based question. Thinking of your data as a researcher, your data in your collections, Who knows that data really well? Who understands the columns? Who understands the data in them? Who understands what may or may not be kosher about that data? What might be issues that happen that maybe only is in your head? If you have a research data set, are you the only one who knows really all the ins and outs of that data and how it was generated? What protocols were used? How many of you would say you're the only one who knows your data really well? Anybody? Just has a one? Okay, some hands go up, yeah? How many of you would say the realm is about 2 to 5 people, maybe, who know your data really well? They could step into it tomorrow and go with it, okay? Yeah, I would guess probably, how many people would say more than 5 know your data really well? Okay, very few hands. So my point here is this longevity conversation that's come up. Who knows what's in your own database? Who knows what's in your research pile? What's our responsibility for making sure that that kind of information propagates itself so that data aren't lost? How do we do that as individuals? How do we do that as communities? So I've been inspired personally about tidying up data by these tools. How many of you know Open Refine? Plus one's an Open Refine. Yes, hands up if you know this tool. Ah, it's a treat. It's a Christmas present, I promise you, for you and yours. Try it out. Humanities, if you're interested in visualizing the data in your PDFs, try Voyant Tools. I've spent some time with Luke Kresslein, who's here, I think, showing him what this tool can do. Caret Squared, something you can Google. SQL, looking inside my database, that's how I first learned to start to understand relational databases. So I could ask my developers better questions about what we might be able to do. And lately, ChatGPT. So it has given me the ability to use what's called regular expressions or regex. How many of you know regex already? Yeah, how many of you have never heard of it? Don't know what I'm talking about. Yep, okay. It's a pretty sophisticated tool that takes a bit of learning, but ChatGPT actually makes it feasible for more of us to use this very powerful tool. So with that, my first question to my developers, and I've asked for this a long time, how can I see what's in my database? I don't want to generate a report and export an Excel spreadsheet and have to visualize it with another tool. I want you to be able to say, what's inside my verbatim locality field? So here I did a query and it says, I want everything where the word park appears in this verbatim locality. So for those of you who do minimal data capture or skeletal data record digitization, so this is park. Yellowstone National Park occurs 430 times. So now I know that, even before I've actually mobilized that data into any Darwin core fields. Here also, I found some errors where data's been imported and there's like a comma. So comma, Giant City State Park. That comma space has no purpose there. With this tool, I can see it inside. I can click on Giant City State Park. I get this word cloud that you see here. I can click on the word cloud too. It creates the data set of all those records for me in one go. And then instead of fixing them one at a time or asking my developer or figuring out some way to do that, I can pass it to this tool, which allows me to do much like you would inside a spreadsheet, do a find and replace and get rid of that comma space. And then one more step. How many of you have had a situation where you need to add something to a field and take something out of a field and change something like capitalize something in a field? 3 things. Instead of having to do that in 3 separate steps, you can use a regular expression, which ChatGPT will help you to write. You can test it here to see if it's going to look like you want. Yay. Apply it. And this is an example where I wanted to pull out just Charles A. Bridges. And I went to ChatGPT and said, can you help me? I give it these strings and say, I want to pull just this string out. And it says, yes, here's the string. I can test it. I can put it right here in the system, right there. It'll show me what it's going to do. And I can say, yay, go for it. So here the point is that I'm trying to build systems that help you do what you need to do in the system that you're in and reduce this back and forth and give you the way to visualize your data. This is also important for other reasons that are going to become clear in just a minute. You can see patterns in your data. This is the month field. Should we see a 13? No. Yay, we don't. So it's instead of exporting it or querying it and looking for the numbers and doing some query in Excel, you can just see. Here, we do a lot of minimal data capture in this digitization effort Crystal was referring to. How do we see the status of that minimal data capture verbatim fields, and how do we get the data out of those and into where they belong? And this is another way to see the scope of what's in those data fields and get them parsed out. I hope you begin to see there the value of being able to see what's in your database. Going now up to this sort of longer term viewpoint. Think about your institutional long-term memory. Who's the staff? How long are they there? What decisions have been made that's only in your head and not written down anywhere? Project decisions like minimal data capture. When you move on, when you change projects, when you whatever, who else knows? Does your database know? Which records have many more data to be parsed out into individual fields? How is that shared? How do we know this? Future discovery and also users that are new to the software or users that are new to the data sets. This is a way someone can learn what's inside the data visually much faster than they can learn if they can only see it in a spreadsheet or a report. So now we're going to step up, going out, we're climbing upward to 30,000 feet. The conversations that were raised here about orphan data, about old data, about amateur data. How do we become the part of the community that when we look back in 100 years, we've given people what they need, so they're no longer saying, this is missing, I couldn't use this is undone, this is not standardized. How do we do that? I would encourage you, if this interests you, to read this paper. I'll give you a minute to read this sentence. So the point here is we know there's information missing. We know we have information that could be used in different ways. We need to sit down with different communities and find out what already exists, what's missing, and then how do we make sure those things are in place so that in the future, we can look back and say, yay. One of the underlying values in doing this work, cross-discipline and interdisciplinary. Some of us have institutional barriers, challenges to communicate with other collections. Some of us have issues with maybe international barriers or collegiate barriers. When you have a common goal, let's sit down and make sure what we have so that when we can look backward 100 years from now and we know the disciplines who need our data and others will be able to use it. When you do that, you break down these barriers. So it's a tool for doing that work. How do you get administration to understand the value of what you're doing? How do you get the people across the hall to collaborate with you? How do you get the collaborators on the other side of the world to sit down with you? So this also then accelerates our discovery of knowledge and our ability to integrate that knowledge. This is also a fabulous paper. That brings me to going to different discipline-specific meetings. And I see lots of people talking about their specific research, and I discovered this, and here's what I learned, and they point you to the paper for their methods section. At the same time, I'd say we can be more strategic at discipline-specific meetings about embedding a culture of a learning mindset, building these biodiversity informatics opportunities, similar to the Entomological Collections Network offerings of the collection manager workshops. How can we do more of that across these kinds of issues that I've just raised in this talk? So with that, I would be excited if you see a way to bring some of these topics to Taxon Works Together. It's our yearly event, May 6th through 8th, and we are open to your topics. Please join us. KU is hosting the Society for the Preservation of Natural History Collections, another opportunity to bring the collection's voice to all of these topics. It's happening in May. And Nico, are you here? Where are you? There you are. All right. And I and Chandra Earl are bringing steamed spinach to you, where one of my goals is to help everyone see we have a lot of challenging topics we need to talk about in our communities and across them, given current situations we all find ourselves in. We have challenging topics. We have difficult topics. We have controversial topics that are hard to talk about. Artists are key to this. I guarantee you, they are the ones that help us in times of challenge. Howard Zinn wrote a book, Artists in Time of War. He talks about how artists help you communicate these ideas and communicate through film, through graphic illustration, through music, through name your favorite medium. they're the ones who help us do this well. How do we collaborate with them? How do we make sure they're part of our outreach efforts, our published paper efforts? So we're going to have a silent art auction at Spinach, and the artists of the Spinach community are going to donate art to benefit student travel grants. And y'all are going to come buy the art, right? And we are going to have an artist corner, so we can talk more about this, and an unconference to talk about how we can collaborate with arts in our realm, in outreach, in our collaborations to write research papers, etc. A keynote speaker, perhaps. And with that, I'd like to say, let's get steamed. We have a new journal opportunity that earlier was raised by Jennifer Jerome and the other person, what's his name? Thank you. And I happen to be editor-in-chief of this journal. So come talk to me. And I'm excited to have an opportunity for all of our voices in this journal to talk about these kinds of things that we're talking about here today. With that, thank you from our Species File Group team, who've made some of my dreams come true. And I hope making spaces for these kinds of conversations in the spaces that we make possible as well. Thank you very much. Yes.
So one of us are locked into whatever database that we use for our institution. Are there ways that these taxonworks tools can be applied to data that either may already exist in our database or maybe migrating into those databases?
Yes. The short answer is we are an open source committed community, and we try to build our tools so that you can either use what we built it generically so that your developers could just add that functionality to what you do, or certainly our code is open and you could point the people who develop your software to what we've done. So, and we'd be happy to talk more about that with you. Yeah.
Thank you.
Mhm.
This speaker saw Greg Cooper and Aidan Houlihan at the Drexel University.
Hi, everyone. It's wonderful to be here. Thanks for all the great presentations that we've seen today. Our presentation from the Academy of Natural Sciences is our journey through finding a treasure trove of field recordings by Dr. Dan Oddie, a orthopterist, and our funding from the IMLS Institute of Museum and Library Services. We appreciate their help and their funding. So we stumbled onto these recordings. There's 207 of them. There's about 250 hours of recordings. They're on cassettes and reel-to-reels. This is Dan. He's a world expert in Orthoptera, a person that recognized the species-specific nature of Orthoptera songs. And for our purpose with this slide, you see that he's collected at about 117 sites around the world. Those are important for the tapes because we see that it was rich in Hawaiian recordings, Africa, all the different countries of Africa, particularly the South Africa, Sub-Saharan Africa, and then Oceania. He cut his teeth with his thesis advisor. They did the Australian crickets in the 1960s. He was no babe in the woods when it came to audio because Dick Alexander, his thesis chair, put out this record with Donald Bohr in the 50s called Songs of Insects, which they recorded. There's the vinyl. Dan started out recording the signals of grasshoppers, and he did this with this Nagra recorder. He soon graduated to a parabolic microphone with stereo tape decks. In 1994, he put out Crickets of Hawaii, and he used this kind of analog method here to record the pulses of their songs, the chirps and trajectory of their songs. These are all Trigonidium species, or most of them from Kauai and Hawaiian Island. So we still had all these tapes. What do we do with them? Well, we got the IMLS grant, and then we started by putting a unique identifier on all of the tapes. Here's an example of a couple of the reel-to-reels with the unique identifiers. It said ANSP, ANT, and then a 6-digit number. We did the cassettes. We put the unique identifier right on the cassette case. We also did specimen level data collection, and all the specimens got a unique barcode also. So now we needed somebody to help us digitize the tapes. So that turned out to be the audio archives at Drexel University with Dr. Toby Say. Here's a musician and radio personality discovering that at the Drexel archives, they also had the Sigma Sound archives, which is all the master tapes from the Sound of Philadelphia, the OJs, people like that. David Bowie recorded there. So reel-to-reels, we relied on Toby's expertise to get us started on this. There's a picture of Toby. We used the International Association of Sound and Audiovisual Archives as kind of the platform for doing this. We ran the tapes through the Arteri MTR12. We used digital audio workstation Pro Tools, which is like standard now for recording in recording studios. The tapes were all digitized in about 4 months by our first co-op, Mikhail Trainai, who's here. So once we had the tapes digitized, we started listening to them. And lo and behold, this guy right here, Brachytupes membranus, was collected by Dan. And we heard him on the tape say, we heard him on the tape say, I caught that big screamer. And what that meant was we had discovered the holy grail of the project, which was we had a voucher specimen and the song. And here it is right here mapped out by Audacity, which is the audio editing software we've been using. Oh, there's Brachytupes right now. It's not a telephone wire. That's the beauty of collecting. I mean, you know, that was 40 years ago. You can break it into the pulses, and you can do more with a parabolic microphone than just recording insects.
And so after
I'm Aidan Houlihan, also a curatorial assistant at the Academy of Natural Sciences in entomology. And so after we've digitized all these 250 hours of cassette tapes and reel-to-reels, what do we do next? Like Greg said, we went through and we were doing specimen level databasing. At this point, we have about 90,000 specimens database focusing on the species we know are going to be represented in the tapes. Right now, we're continuing to do that, and there's ongoing georeferencing using geolocate. We live manage our specimens, at least in this collection, on Symbiota in the Ecdysis portal. But if you're familiar with Symbiota, you know that while they have really robust tools for images, not so for audio. So thanks to IMLS and they're allowing our use for some of the grant money, we were able to fund developments for the code base for Symbiota, working with the wonderful team at the Symbiota Support Hub. I'd like to shout out Katie Pearson, Ed Gilbert, and the programmer who did most of the development of this, Logan Wilt. So this is not publicly available yet, but it'll be pushed out hopefully soon once it all gets all sorted. But we're adding publicly available audio playback and download to specimen level records, multimedia search capabilities, and the expansion of the database schema to be Darwin Core compatible, taking in all meme types, well, audio right now, but opening up the database schema to other meme types as other funding sources become available for those. So that's really exciting. So we can start to put these species clips that we're extracting from the tapes into Symbiota. So how we're doing that is mainly in Audacity. So this is kind of an example of what a workstation workflow might look like. So you have the tape open there. We find it most useful to use the spectrogram view, so because you can really see the highlights up in those high frequency ranges. They show up quite well. So in addition to the sound, as we heard, Dan had a lot of voice notes. Caught that big screamer, but also he's noting locality, temperature, time of day, often the habitat or the substrate, or if there's a motorcycle driving by, or he's talking to people who came up to him asking what he was doing. So he's giving us all this information, but we quickly found that it was difficult to glean all that out just typing out manually. So we were able to use an open source AI model to do audio or speech to text. We found that worked really well, a little bit less so for Latin names, but we're reading through all of these anyway, so we can do edits on the fly, but it takes out the bulk of typing all of these out. So those are all captured in these label tracks, the bottom one being, the voice notes that Dan has made, and the top one being these clips that we're choosing to extract. Yeah, so we're then taking all these voice notes and classifying them so we can associate them with those specimens that they apply to. It can get a little tricky because some of them will apply to multiple specimens. For example, locality or temperature, those might apply to a whole series of specimens. So we're classifying them into separate types, and we're going to encapture those in parsable JSON format and keep them in dynamic properties in Symbiota, so that if someone wants to pull out all the locality notes or identification notes, or most importantly, I think, capture notes saying, we caught that big screamer, oh, I got that male, so on and so forth, we'll know that we can go look back in the collection for those. We also have acoustic notes. He might make notes of the pulse rate and frequency as he's counted it in the field, or identifications that he's made in the field, like here, caught that cricket, Akita domesticus, we think. Which is, again, one of those holy grail specimens. We can go back in the collection to the Silo Swamp area. I know this is a Kenya tape, I think. And then also when we're pulling out the clips themselves, we label them. We try to only go for ones that have high signal to noise ratios. We don't want a lot of background noise. We are looking for ones that represent a single individual. We don't want a lot of clips of the same individual because then we're just replicating the same observation. So once we have all of these labeled and the voice notes associated with each clip in a sidecar spreadsheet, we can take all of those and run them through, a Python script that can hook into Audacity. So it can automatically go out and clip all of those out into their own separate WAV files, associate them with all the data we collected about them. And then those can be batch uploaded as human observation basis of record occurrences into Symbiota. And also we can automate the generation of spectrograms and waveforms for all of those, just like if you've used Xenocanto at all, those also come along with those. And then our Outlook, like I said, we're uploading these to Ecdysis, which is a Symbiota portal. Those will then be pushed to GBIF and IDIG-Bio, and because we're following the Darwin Core multimedia schema, that'll come out just like they ought to, everything all nice and good. And as well, we're going to work with Xenocanto to upload the orthopteran sounds there, because they just in the past year or so opened up their database to accepting orthoptera sounds. So that's good, because for those ones where we don't have good solid identifications that either Dan did in the field or we're doing now, those can be opened up to, we'll give the most specific identification we can, and then they have community-based identification that can happen there. At the current rates we're estimating about 8,000 to 10,000 clips at the current rates, which is about 1 a minute. And then potentially 1,600 of those could be associated with physical specimens. We got that number from searching through all of the voice transcriptions for caught, collected, got that, so on and so forth. And those would be phenomenal if we have 1,600 Holy Grail specimens. And then kind of looking into the future, this might also be a really robust data set for machine learning. We're going to have very well annotated and transcribed data sets of these species, albeit just kind of based in the localities where these tapes are from, but it's a good place to start. And I'd like to give some acknowledgements to the people who have contributed so much to this project. Dan, John Gelhaus, Jason Weintraub, who work in the collection with us, the student co-ops, all 4 of them, the Symbiota support team, Bob Planck from Xenocanto, and Toby Say from the Drexel Audio Archives. Thank you very much. So the question was about if this workflow is specific to individuals or for groups or colonies. Right now, he was really only recording the tapes that we've gone through thus far. He's really only recording a single individual. But what we have noticed, which I think kind of gets into your question, but it's not entomological related, there's a lot of bird sounds in the background a lot of times because he's pointing at a tree, which has a lot of things in it. Usually he's pointing at a single specimen, and because of the parabolic mic, it will only pick up that. But there's a lot of good bird recording data in there as well. So I think it certainly could work for that, because you can pull these things out programmatically and sort them later if you have someone who works with, ornithology.
The Academy also hosted microsculpture, and we pulled from Dan's tape a soundscape to play behind that. And there was all kinds of, we were talking about orthopter mainly, but there was all kinds of animals and birds that all led to that really cool soundscape.
Great job. Quick question from a data standpoint, since you started with the clips and then we're using a specimen, which is the parent, which is the child?
Oh yeah, so if we have, that's a great question. I didn't clarify that. So if we have a specimen that is physically in the collection, the clip will be associated media with that specimen, as we've already databased it. And so then the metadata about the clip itself, which will also be associated with all the human observation occurrences of just the clips with no associated voucher specimen, all the information, the voice notes, the locality, time of day, those things, but also the type of microphone, the playback speed, the recording speed, that audio metadata. But if you think there's something wrong with that, I'd love to talk to you about it. Thank you very much.
Oh, there might be another one.
Oh. Yeah, exactly. Similar to, and I realize I didn't reread the questions to those online from the previous ones, but this is about looking forward to the future using an AI model based on this data. And would it be, you're feeding your own data into it and getting an identification back? Yeah, that would be the gold standard we'd look for, similar to the Merlin Bird ID app. If people have used that before, they have the ability to, at least for some groups of species, go right from a bird call to an identification. Thank you.
So, let's just put it in a change. So we're now, your marking, okay, now for the students that don't know them.
Hi, thanks for the introduction, Maru. So I'm Geoff Martin from the Natural History Museum, London. My talk is going to be about, can AI help with automated identification and management of natural history collections? Right, got it. Okay, so first off, I'm going to talk, this talk is going to be totally from the curator's point of view. I know nothing about programming AI or anything else. So I'm just going to go back a few years to the iCollections project, which was the Natural History Museum's first mass digitization project, which ran from 2013 to 2016 with over 600,000 specimens of British and Irish Lepidoptera digitized. Here we see the workflow. We've all seen this kind of thing before. And note the specimens were all rehoused at the same time from cork line drawers into plastozote line drawers. The specimens are only imaged on the side that it was set, so it's mainly dorsal views. And the label data was also transcribed as part of the project. Generations of curators, visitors, and volunteers have worked on this collection literally for centuries. And it's the British and because the fauna is so well known, we assume the identification would be correct in virtually every single case. This also gave us an opportunity to clear mixed successors at the same time. Here, the top drawer is the old main collection laid out in cork, and then below it a drawer of mixed successions. And these were amalgamated as part of digitization process into new drawers, new plastozote line drawers. We should also bear in mind that the British and Irish collection, we've got quite a small fauna in the UK, but certainly we like to collect everything that moves. And it's got thousands of aberrant specimens in the columns 1 and 3 here are typical specimens, and the columns 2 and 4 are the most extreme aberrations I could find in a matter of time. And we've got literally every gradation between the typical specimens in columns 1 and 3 and the extreme aberrants in columns 2 and 4. And all this data was uploaded to the Natural History Museum's data portal, where you can actually download the images and data yourself in spreadsheets and all the images as well. So moving on to 2024, this guy came into my bay at work and he claimed he'd found thousands of mistakes in the data sets. So I was a bit surprised. And Jack Hollister, he's a PhD student at the Natural History Museum. And he'd used computer vision and AI to examine all the images. He used a minimum of 400 specimen images per species, which for most collections, that's a huge number of specimens for each species. And he found that he was using this to examine 350,000 plus specimens from the collection to see if they match their taxonomic name in the data portal. He used a heat map based class activity, activate mapping, CAM analysis was used, and it took 24 hours to run through 10 million plus images on a mid-range gaming computer. Specimens selected for scrutiny were based on a reoccurring prediction value, an RPV. And he found that, as I say, hundreds of specimens seem to be incorrectly identified or mislabeled. So the reoccurring prediction value, I think I understand what he's talking about after reading this again and again and again. So each image was run through 100 iterations against the program to see if it was correct or not. And we have these various intervals because there was a lot of noise on this, because if there was one mislabeled specimen, it would still produce a result here. So we basically looked at the RPV of greater than 80 iterations that are incorrect. And then he came to see us, so I grabbed somebody else who's good at moths, Mark Sterling, and our digitizing serial assistant, Glory Turnbull, and myself looked at the butterflies. So he asked us to look at 4 different questions here from his computer vision pipeline. The first one was he found that the identification was incorrect. The specimen was incorrectly identified and placed in the collections under the wrong species. Number 2, the iCollections database was incorrect. The specimen was correctly identified in the collection, but under the wrong species name in the database. Number 3, identification was uncertain. We looked at the specimens and we couldn't really decide whether it was incorrect or not without either a genitalia dissection or DNA barcoding. And then number 4, where the computer vision program may have been incorrect. The pipeline highlighted a specimen incorrectly identified when it was actually, in fact, identified correctly. So this in 16 hours, we managed to go through 210 specimens in this higher than 80% RPV value. So what do we find? So first off, this is an identification that's incorrect. And I was quite surprised to find this draw of Cataro rubitata. Sorry, specimens of Cataro rubitata were actually in the wrong draw of Eryphila badiata. And this had obviously been in the collection for 100 years like that, and nobody actually noticed it before. And here's another species pair, Beloria euphrosni, pearl border artillery, and Beloria seleni, which is the small pearl border artillery. I think you get that in North America. So this is the draw of seleni. And if I keep pressing the button, you'll find computer vision pipeline picked out quite a few specimens here and there that were incorrectly identified. Now it's been pointed out, it's actually quite obvious to me, but at the time it wasn't. And again, this must have been like this for 50, 60 years at least. And as you can see here, the upper sides are quite hard to tell apart at a quick glance. If the undersides had been imaged, it would have been quite easy to see the differences. And we could play a game of Where's, well, we call it Where's Wally. I think it's Where's Waldo in North America. But in that draw of 133 Paris nappy, there is one Paris rappy in there somewhere. Can anybody see it quickly? No, no takers. Down there. And again, once you've got the draw in front of you, it is actually quite obvious that that shouldn't really be in there. So now we move on to where the database is incorrect. So this is Nymphalis polychlorus. Everything in there is correctly identified, but unfortunately, one of the digitizers at the time had attached the wrong species name to the database record. So these are all down as Aglaeus urticae. Now, the computer vision pipeline didn't get it right all the time. As I say, we've got this huge number of aberrations. So in this draw, it picked out that specimen and said it was actually Cupido minimus, when it is actually Plebidus argus, the silver-studded blue. But it was an aberrant specimen, and the females tend to have these orange lunals on the hind wings, and that specimen didn't for some reason. But again, the undersides have been seen. The undersides are very distinct from each other. Another one it got wrong. Now, remember, I didn't mention earlier that the scale bars and labels were cut out of all the images. So it just concentrated on the images because there was too much noise from the scale bars and images. Now, these look like sort of the same specimens, but actually, if you look at the scale bar beneath, on the left-hand side is the large blue, and on the right-hand side is the small blue, because the large blue, Vengaris arian, this is a really aberrant example, and it should actually, most specimens actually look like that. So that's pulled the pipeline there. And where identification was uncertain, we managed to get 32 specimens put onto a DNA barcoding plate and got the results from that. So here we have, this is Lysandra belargus, the Adonis blue, and the CVP lists them all as Lysander corydon, the chalk hill blue. I mean, the females are very difficult to tell apart sometimes, but you can separate them on collection date because belargus is a double brooded species in the UK, so you get a May-June emergence and an August-September emergence, whereas corydon tends to fly in July-August. So if there's an August specimen, you could be not quite sure which one's which. And you see the first two specimens here have no date, which isn't very helpful. But anyway, after they were all barcoded, they all turned out to be belargus. They were right in the first place. And another one here, this is another species pair. This is Erysia gestis, the brown argus, versus Erysia artaxerxes, the northern brown argus. And you can see here the distribution in the UK, it's quite clearly, one's a northern species and one's a southern species. Now, the first two specimens in that column have got the locality on. So again, from locality, we know where it is. Jack wasn't convinced that was true. He said, let's barcode them anyway. And the one at the bottom has the useful locality of Angleterre, which is England, which isn't exactly very helpful. And what was interesting with this species, there's a whole load of, we got quite a lot of bred specimens in the collection. And people in the past had decided to try and do rear hybrids. So all the hybrids in the collection were also flagged up by this pipeline as well. And it turns out they were all correct in the collection. The 3 specimens I show there were all correct. And here's the last one here. These are all barcoded as well. This is a pair of moths. This is the marbled carpet and the dark marbled carpet, Distroma truncata, but they're all listed as Distroma citrata, the dark marbled carpet. And DNA barcoding revealed they're actually all correct in the collection. But if you look at the undersides of these moths, you see they're actually quite easy to tell apart based on undersides. But again, only the upper side was imaged. So in conclusion, this computer vision pipeline I thought was very powerful for what it did. This is just a sort of pilot type project. I've managed to examine 350,208 specimens in 1 hour, and this was repeated 100 times again in 24 hours. Incredible, really. And of the 210 specimens we looked at, 145 were found to be incorrectly identified or labeled. There's a notable limitation in the pipeline. It should have had the ability to integrate information on specimen size differences. I said the scale bar was cut out. Flight periods would have informed the pipeline as well. But obviously with climate change, these broods are starting to merge together. It's very uncertain when things are going to fly these days. And the geographic range could have been taken into consideration. I mentioned earlier, I said that the images were just from the side that was set on the specimen. But now all NHM digitalization of Lepidoptera, they do the dorsal and ventral side, so that wouldn't be so much of a problem now. And I said a large number of specimens are needed to train for the machine learning, and 400 specimens per species, as you can imagine, is quite a lot of specimens. But then again, you could actually share this across museum networks to help with training. And I say DNA barcoding would also inform the computer vision pipeline as well. So you had an idea of what it was via DNA barcoding. And the curatorial interrogation time was quite lengthy, so we're not out of a job yet. So there is some good news here. And we see the collaboration between automated methods and curators being the key as the future of curation and maintenance of very large and growing natural history collections. A few acknowledgements and any questions? So the question is, were the images used in the computer pipeline whole draw images or individual specimens? They're all individual specimens at the time. So there's an individual picture. Maybe if I just show you, yeah, on the data portal, the images on the left is what you see or what he downloaded the data portal.
I guess was there segmentation done?
Oh yeah, the images you download for the data portal are all individual. I've just clumped them together for the purpose of this this talk. Let me just see if I can find an individual one to show. Yeah, I mean, this is what you get. If you download the image, you get one image per database entry.
Follow-up questions down. First of all, thank you. I think you might be asking, Brennan, I know that at the NHM, you did a lot of image segmentation, using automated AI techniques, machine learning and such. So I think that you're asking, did this AI project use those images specifically, or did it use the information that you already got from segmentation?
Well, they weren't segmented. The images, the original iCollections project was each specimen was photographed on its own. There was no whole draw scanning then. We hadn't done that then. So remember, this is 10 years ago now. So. Right. The question was, how sensitive is this process to the quality of the images? Well, I don't actually know, but certainly these images, 350,000 of them were taken between 2013 and 2016. Certainly the technology now has really moved on. So it seemed to cope with the variety. I mean, the lighting setup was the same, but obviously quite often the images look quite different, even though it's the same species, but there's a huge number of variations, the aberrations of the actual species themselves that was the amazing thing how this worked, obviously with a few drawbacks.
Thank you for all of this month's last month of day. Now we're going to talk about the rates. We're going to be back 4 days in business meetings. So I would say we're sleeping at 5 to 6. 5 times. I want to talk 3 people for the